Hello and welcome to the AutoCAD Essentials. I am Prabhakaran, Autodesk Certified Associate with you. This is our session 4. We are going to discuss point fixing method and the basic settings of the AutoCAD 2022. Okay. This is going to be very first command in our AutoCAD called about. Already we seen last session about this command. This is just information about the AutoCAD program. What is the copyright informations and the product informations we have seen last session. Okay. Next very important command is units. Before going to draw any drawing, we need to decide what unit we are going to follow in our AutoCAD. Either we are going to follow feet and inches or millimeter or whatever it may be. Okay. So we need to set our unit system first. So we are going to use a command called units. Generally, we have two types of units, right? One is length measurement, another one is angular measurement. Okay. In general, linear units or length can be measured in two ways. Generally, civil engineers may use feet and inches. So those feet and inches are available under engineering and architectural options in AutoCAD. Similarly, in mechanical engineers, all other engineers, they may use millimeters. Okay. So those millimeter options, those millimeter units are available under decimal and fraction options in the AutoCAD. Apart from this, we have a scientific. Okay. You can see here in civil, we have two methods, engineering as well as architectural. Why it is two? What is the difference here? The similar way in mechanical also we have two options, decimal and fraction. Both are millimeters only. Why we have a two? We will discuss these things later of this session. Okay. Now we are going to discuss about the scientific. What does it mean by scientific? Scientific is nothing but a scientific notation. Just it is a system of representing a large number or very small number in terms of exponential way like this. So we have here 300 that can be represented or written in the form of scientific notation as 3 multiplied 10 to the power of 2. Similar way, all the numbers can be expressed in terms of exponential way. This is a general information. In AutoCAD, exponential form. So exponential form or scientific form in AutoCAD, it is a unitless, just it is a exponential value. Okay. In AutoCAD, those exponential numbers will be expressed in terms of e power. That means 10 power. For example, if you are designing a very big size of product or just like a galaxy size, so those values can be expressed in terms of e power. That means 10 power. Similar way, if you are going to design a very small or tiny parts just like a molecules or something, it will be expressed in terms of e power minus values. In general, in AutoCAD, we will use this unit as an input value as well as an output value. That means the AutoCAD will show the results, will show the dimension in terms of a particular unit size. In the similar way, we can enter the values in terms of a particular unit also. Okay. Next, angular unit. As we know that we are using the protractor for measuring the angles. We are measuring from right to left. This is what generally we are using. So right to left is a positive value. The similar way in AutoCAD also we are measuring the angle in anti-clockwise direction. That means in AutoCAD the positive value will be represented or will be considered as a anti-clockwise. Similarly, we can measure the angle in clockwise also. That means in AutoCAD, negative values will be considered as a clockwise angles. Okay. Only these two things are available in angular measurements. Fine. Now we will enter into the AutoCAD program. We will discuss these units command detailedly. Later we will discuss the further commands. Okay. Welcome to the AutoCAD 2022. This is our AutoCAD screen. Just go to the new. I am going for the units command. Just type units, enter. You can see on the top length and angle. What are the types of length measurements are available? Architectural, decimal, engineering, fractional and scientific. There are 5 types of length measurements units we have. Let us discuss about the civil engineering units, architectural and engineering. First, let us discuss about the engineering. Engineering is what? See the sample output 1.5 inches. Double quote over the number, it means that inches. One quote over the number, it means that feet. So it is a feet and inches in terms of 1.5. The fraction will be represented by the numbers. The same fraction will be represented in a decimal format. It is called as architectural. You can see here. Once I choose the architecture, you can see the sample output 1.5 inches. The 0.5 value will be represented as half 1/2 in a decimal format. Okay. So engineering and architectural, both civil engineers may use. Now we will go for millimeters, decimal. You can see here 1.5. It's a sample output. Similarly, this 0.5 can be represented as 1/2 millimeters. How it can be? We have to choose the fractional. If you choose the fractional, you can see this 0.5 will be represented as 1/2. These are all millimeters only. Okay, then finally you can see the scientific. You can see this sample 1.5 e to the power of 0.2. Okay, these are the length. Similarly, angle. If you go to the angle, there are plenty of methods are available. You can represent the angle in terms of decimal degree or degree, minutes, second, gradients, radians or surveyors units. Okay, generally we use degrees or angle measurements in a decimal degrees only. Okay, some cases civil engineers, they may use surveyor units. Okay, but in general we use decimal degrees. So let me keep here decimal degrees and let me keep here decimals. So I'm going to show you the samples. Let me draw a line approximate length. Okay, I want to get the information about this line. Just go to the information. It shows 19.467 decimal units. Okay, I want to get the information about the same line in a different units. What I can do? Go for the units, change the length type units in engineering. Okay, now the same line will show in terms of feet and inches. This is what I said before. We can get the output of the object in any desired units. Okay. The similar way, you can enter the values in feet and inches also. Okay, right. Similarly, I'm going to set for a scientific. Okay, I'm going to get the information of the same line in terms of exponential form. Next, decimal degrees. Okay, in AutoCAD, in general, positive value will be considered as a anti-clockwise. If you want to consider the positive value in clockwise, just check this box. So hereafter, positive value will be considered as clockwise. Okay, right. Here the next option is directions. Okay, these directions I will tell you at the end of the point fixing method. Okay, so we should know what is this 90, 180, 270 degrees. So then only we can able to understand these informations. We will discuss this later. Next command is limits. What is this limits? Why we need these limits? Just I'm going to draw a line of length 50 mm. Just I'm drawing the line of length 50 mm. It crosses the boundary of the drawing area. So what I have to do now? It may happen sometime like this, or sometimes you may draw same 50 mm line. It will be very small. See here, same AutoCAD. One drawing it is very big, another drawing is very small. Why it is like this? It's very simple. It is here the drawing sheet, the drawing area is very big. That is why your 50 mm is very small. Here your drawing area, that means your drawing sheet is very small. That is why your line looks very big. So it should not be like this, right? Before you going to draw, you have to decide what size of your drawing, or you can choose on what paper you are going to draw. This is called limits. So we have to set the limits of our drawing area. So this limits will help us to control the visibility of our drawing area. Okay. So limits. So limits is the command to control and limit the display of point locations. We have different types of paper. We know that A0, A1, A2, A3. Generally we use A3 or A4. Okay. So those paper sizes we know that. So, okay. Generally we use A4 or A3. 297 cross 420. Okay. So this is in millimeters. The same thing in inches. Sometimes we may use A4 also 210, 297. So that is 9 cross 12. Okay, right. So we need to choose either we want A4 paper size or A3 paper size. Generally, we use A3 paper. Okay, right. So what we have to do? So we have to set our drawing area, what limit you need. See, this is our graph sheet. The bottom left side of the graph sheet we used to keep 0, 0. The top right corner of this graph sheet, what is the value? 50, 50. That means what? So this graph sheet has the size of 50 cross 50. So this is the paper size. So within this 50 cross 50, we can draw any diagram. So similar way, we need to set our drawing screen as per the paper size. Okay. So first give the command limits, just enter. Once you give the limits command, it will ask reset model space limit. That means what? We are going to reset. That means already that particular screen in a different size. So we are going to reset the particular drawing area, that is called model space. The drawing area or the design area is called as model space. Okay. Once you give the limits command, it will ask specify lower left corner. Imagine this is your graph sheet. On the graph sheet, what you do generally, lower left corner will be our reference 0, 0. You can see here already it is available 0, 0. So lower left corner, you no need to set anything because already 0, 0 only. Just give enter. Then you have to go for specify the values of upper right corner. It is asking upper right corner. Default values are 12, 9. So we need to specify the A3 paper size. Okay, 420, 297. Once you enter the value, just press enter key. Then we are chosen the paper. So before the screen was X is 12 unit, Y is 9 units. Now we are changing into 420 and 297 units. So we are changing the paper that has to established on the screen, right? So how to do that one? Once you give the limits command, immediately we have to go for zoom. Okay. So once you enter the zoom command, there are plenty of options will come. We will choose only the first option called ALL, all. That means whatever the size we are chosen, that is going to be zoomed on the screen now. Okay, just give all, enter. So now your paper size is set on the screen. Otherwise, it will not be set. Okay, until you give zoom command, the size will not be applied to the screens. Okay, right. Now we will go to the AutoCAD screen. We will set our drawing area into the A3 size. You see here, our 50 mm line is looking very big. So I am going to change the limits 0, 0. It is already there. Enter. Default 12 units X, 9 units Y. Now I am going to change 420, 297. Enter. See now, I given the value even though there is no change in the screen. So when the changes will happen, once you give zoom command, okay, just choose all or type all. Okay, right. Once you chosen, it will be set now. Okay, you can see this is our line. Another important thing we have to notice that frequently we may have two types of brackets in the commands. You can see here square brackets, less than, greater than bracket. Square bracket means it's optional. That means anything you want within the square bracket, we have to type and get it. Next is less than, greater than bracket. So whatever the values are available within these brackets, that is a default value. That means existing value. If you want the existing value, you don't need to type anything. You can just skip the steps. You can come to the next steps. If you want to change the default value, then only we have to set here. You can see here, lower left corner, I did not give any value because already it is 0.00, 0.00 only. So default value, that's what I needed. So I didn't give anything. Upper right corner was 12, 9. I want to change. That is why I gave 420, 297. Okay, right. So our basic setting for the AutoCAD program is finished. The first thing is unit. The second thing is limits. Okay. Next important thing is point fixing method. If you understand this point fixing method, any kind of drawing you can draw in AutoCAD very easily and comfortably. Okay. Right. What is this point fixing method? Any drawing, if you want to draw, it needs some points. For example, take a square or rectangle. How many points it needs? It needs minimum 4 points. If you connect these 4 points by line, you will get the square or rectangle. Similar way, this is a triangle. How many points do we need? We need 3 points. Just connect these 3 points with the proper lines, we'll get the triangle. Similarly, pentagon. So pentagon is 5 sides. We need 5 points there. So just connect these 5 points by line, you will get the pentagon. Any shape, if you take any shape, it needs a points or vertices. To connect those vertices, we'll get the shapes. Similarly, circles, we need a center point, we need a radius. Okay, so every object, it needs some points to fix in a proper location, so that we'll get a proper regular shapes. Okay, how to fix these points in AutoCAD? If you take the graph sheet, okay, in a graph sheet we used to mark lower left corner 0, 0. Every divisions we used to mark 10, 20, 30, x-axis and y-axis. Then we will get here exactly 10, 10 is this point, 20, 20 is this point, 30, 30 is this point. We know here because we mark every divisions. But you see the AutoCAD, it shows only the x direction, y direction. It is not showing any x division values, y division values. Okay. So these lines, what you are seeing, it is an imaginary graph sheet. We don't know what is the each unit it is. It may be 1 mm or it may be a 10 mm or it may be 100 mm. We don't know that. Okay. Then without knowing this, how can we fix these points? How can we fix the points on the screen exactly? We have some methods. Those methods are called as absolute method, relative method, polar method. Only 3 methods are there. How to fix a point exactly on the imaginary graph sheet without any x and y value reference? We have some rules, syntax we have. So using this syntax, we can fix the points on a screen exactly. Okay, from the next session, we are going to discuss each and every point fixing method elaborately with examples. Okay, this is our end of session 4. Next session, we are going to start with the absolute method of point fixing. Okay, thank you.